This problem is for you.
Then neither of us would be able to drive home with our flat tires.
Approximately. The statics problem.
We both have a flat tire issue.
Yeah, and if I was the only one with a flat tire, I'd make sure you had one too.
I'm probably not doing myself any favors there because, so when I drop my daughter off at preschool, we have these placards on our, that we have beginning of the lot. And so I have a tendency to leave it there so you can look and there's this big Michelson on my dashboard. It's like, I wonder whose car that is.
On the silver car?
Yes.
Whoa.
The one that has 3 flat tires.
That's why we appreciate you as a professor. You're willing to make it easy for us. Make it easy for us to find you.
Yeah.
That's not how much we appreciate your efforts.
And to let the air out of your tires for the difficult exam. Yeah.
Say you're ready to off-road.
All right, let's get started. Okay, so just so everybody's aware, today we are in exam review land. And I want to make sure this part's clear. So this is one of the few classes that my exams are weighted differently. Usually I have 3 or 4 exams and they all have equal weights. Not in here. The second exam is only worth 15%, and that's just because there's just not as much material on it. Bolted and welded connections don't add up to a significant chunk of lecture material. So unlike exam 1 and exam 3. Exam 3, which covers columns and beams, there's kind of a lot on there, so that's why it's worth 25%. All the homework's graded up through the one that you submitted on Friday. Homework 4.2 is due today, and the solution's now available. So in terms of your grade in the class, everything's current and up to date. So with that, we can go ahead and get into the logistics of the exam. Remember, we have a celebration on Wednesday. We do not have class on Friday. So, because we're up to date, we're current. We have had a relatively light winter, so we have not had any cancellations or anything like that. So it's made our life a little easier in terms of covering the topics of the class. Okay, let's talk about the exam. Just make sure that you are allowed to use the manual. Obviously, you can't use your notes, but you can use a formula sheet. I would suggest bringing a straight edge. I will tell you, at least one problem requires a sketch as your answer, okay? Which can't be all that shocking, given the fact that this is a test on connection design, and the answers are the connections, right? That's the answer. So it shouldn't be that much of a shock that you should need to provide a sketch. So a straight edge is probably not the worst idea in the world. 4 to 5 conceptual questions, 2 to 3 computational problems. Again, make sure you bring your calculator, and again, your formula sheet. You can put whatever you want on your formula sheet. I would suggest that you do not put on fully worked out example problems. I think that is particularly troubling on an exam like this, where a little bit of a change in thickness or material strength and suddenly all your values are off. Put the equations, put the methods, don't put any worked out problems. Okay, let's talk about the topics. The topics are bolted and welded connections. So make sure that for both topics that you understand the fundamentals of the behavior. It's like with bolts, make sure you understand bolt behavior, the 2 different types of bolted connections, what is their difference, what are the installation methods that are utilized, generally what is the difference between a bearing type connection and a slip critical connection. But make sure that you can analyze and design both of them. As for welded connections, make sure that you understand the fundamentals of welding methods and weld behavior. So that's all the different welded joints, the different weld positions. You do need to understand the basics of weld symbology, but nothing super significant. But really make sure that you can analyze and design connections using fillet welds. For bolted connection capacity, what I've done is I've basically combined everything here on this one slide. We have bolt shear capacity, bolt tensile capacity, bolt slip capacity, bolt bearing capacity. That's the only one that you really kind of have to go out of your way to compute. you have to chug through. The layout requirements, so minimum bolt spacing, maximum bolt spacing, your preferred bolt spacing. Edge distance requirements, remember the minimum, that's the only one that you look up, and you look up the minimum edge distance from table 3 point, or J3.4. The maximum is one that you can compute. For combined loading, here, that is also a bearing type connection, so that's why I just sort of lumped that in together. Remember, in combined loading scenarios, we're computing a modified tensile capacity and comparing that against the tensile load. And so here's our expression. The only thing that's not a lookup is FRB, which is the applied factored shear stress. So you're taking the shear load per bolt, dividing it by the area per bolt. For designing bolted connections, this is our process. And this little box over here on the right is basically saying that, okay, so you determine the factored load and then you determine the capacity per bolt. If it's a bearing type connection, it's just the shear capacity per bolt. But if it's a slip critical connection, it's the minimum of either the shear capacity or the slip capacity. You compute the required number of bolts and then select a pattern accordingly. So essentially for us, a grid-like pattern that tries to minimize our plate area as much as possible. We lay out the connection according to prescribed requirements. That's typically either the minimum, the minimum edge distance and either S-min or S-preferred, which will be delineated in the problem. I'm not going to make you guess that. Check the bolt bearing, and then if necessary, iterate. And that's basically it for bolted connections. For welded connections, we have our weld metal capacity and our base metal capacity. For the base metal capacity, there's two limit states. Base metal yielding and base metal rupture or fracture. And so what we've been doing in class is really just taking each of these three expressions, computing them, and then taking the minimum, just as we would for just about any other limit state. Here are all the terms that go along with that. For the limits for welded connections, remember minimum weld sizes we look up, maximum weld sizes we compute based on the thickness of the base metal, and remember the different reasons for those. For designing a welded connection, we are determining the factored load. We are choosing a weld size. Again, what is a little counterintuitive is that we are choosing a weld size based on limitations, and typically we choose the largest weld size, not the smallest, because the largest weld size means the shortest weld length, which means it's quicker to deposit, easier on the wallet. So we're choosing the largest weld size up to 5/16 of an inch, determine the capacity of a single inch of weld, and then divide it to do the total number of inches. We can do that either in a symmetric fashion or a balanced weld. I say usually in a symmetric fashion because other than angles, everything that you're usually depositing is usually symmetric. Angles, I think, are probably the only real shape where symmetry isn't present, and so you would need to lay that out in a balanced connection or a balanced layout if specified. You don't have to lay out an angled connection in a balanced arrangement, but usually that's a good idea to eliminate bending and whatnot. Limit the weld lengths to the nearest inch. No weld lengths deposited to the nearest half inch or anything like that. Just round it up to the nearest inch. And remember, either longitudinal welds or longitudinal and transverse. No transverse welds by themselves, because that is a connection that exhibits poor ductility, which is what we don't like in steel structure behavior. That is it for the second exam. Again, like I said, not a lot. It's not that, I mean, bolted and welded connections just don't comprise that much material in the class, but when we get to columns and beams, that'll add up. Okay, I'm going to shut up, open it up to you all. Any questions that you have, the floor is yours. Or early lunch, whatever works for you. Yes?
I just had a question about the homework we just turned in. So I was looking at the solution, and for like the bottom length, it's 11 inches, or 10.5 inches, and I thought we rounded to the
Oh, did I
inch.
put 10.5?
Yeah, I was just curious if that's what we
Whoops.
should do.
No, it should be 11. Whoops. Let me see. Yeah, it should be 11. Why did I say 10.5? Yeah, it should be 11.
Okay.
Yeah. I started doing that. I started telling everybody to round up to the nearest inch about 3 years ago because I just thought it was easier just for everybody to get the same answer. But I guess I should have looked because I pulled that problem out of a problem I gave about 6 years ago. So that would be why. So I'll fix that solution and re-upload it. It should be 11. So.
I had a question kind of about that too, not about the grade, but for determining the length of the two welds, you use the kits to find it. Is it just for this one where like they're just the longitudinal ones? Could you just take like the 4 inches and subtract that from your required length?
You could. I just think this is easier and it ensures that you're handling rounding appropriately. That's just me.
That's what I was saying with the whole rounding thing, because it's like you'd have to either take your required and then probably be better to subtract 4 inches, not 3.88 or something. So.
Yeah, I mean, I guess you could do that. To me, the way I've treated it when I've done these connection designs is I look at each weld independently and say, this weld needs to support this much force. This weld needs to support this much force. So how much load needs to go, or how much weld do I need for each of those welds to support that much load? So that's why I treated it first as an equilibrium problem, then take those forces, determine the weld length for each of them. So, I mean, yeah, you could, like at this point up here, say the connection as a whole needs this many inches of weld, so figure this one and subtract. I mean, you could do that. I just felt it was more appropriate when laying out a connection to just look at each force and say, figure out the force that each weld needs to support. So I don't want to say your way is wrong. It's not wrong.
Looking at it, I could tell I didn't think it would be wrong. Like, I mean, I did it how you did it. I'm saying I was like, I better ask just so that way I don't decide to do it.
That was the question that Mr. Odell was bringing up earlier, and another way that I wanted that I answered that was I think that this way handles potential rounding errors a little better. So again, theoretically, it's not wrong. I mean, one thing to be clear about, if we were all doing this in Excel, like it wouldn't matter. You know what I mean? So. The only thing I would say is if you wanted it, for you and I to get the exact same answer, I would subtract off this, not the 4 inches. Then it numerically wouldn't matter. So. How's everybody feeling about the exam? Nervous? Like, haven't thought about it until after we submit the hydraulics project, then we'll think about it. It's like I don't know things. I know things. I get it. I've been around.
It's a busy week.
I'll think about it tomorrow.
You'll think about it tomorrow. As long as you at least think about it while you're taking it. That would be a good thing. Good. I don't want that to happen.
Until the second I turn it in, I'm like,
I don't want that to happen. I mean, I want to be clear when I say this, because, like, to me, I'm afraid there's a double-edged sword with what I'm about to say. I think that this exam is, of the 3 exams we have in this class, I think this is the easiest one. So I don't want you to worry about it, but on the other hand, I don't want you to not prepare for it. Does it make sense? I mean, what?
it's not exam 1, is what you're saying.
It's not exam 1. I don't think it's exam 1.
I feel like this exam is just going to be a lot more straightforward with the way you would think about it.
But what I don't want to have happen is, well, I just don't need to prepare for it. That's what I don't want to have happen. That look on your face, Mr. Lingenfelter, I see it, and
Still
it's...
throwing a curveball.
I'll prepare. I will. Same as any other exam.
Well, okay.
That's all you need to hear, right?
It's not about what I need to hear, it's about what you need to do.
I will do this.
Slight potential foreshadowing. We walk in after spring break and you're sitting on the table like you were in B-form.
Have my little journal book that's like, I haven't turned the recording on yet. I'm like, okay, everybody, let's have a discussion.
Not mad, I'm disappointed. Yeah. And then you take my arm on those sheets again.
Your classic pressure.
That's like a locust moment in my career, apparently, was when I sat down on that table. It was like, man, not you, Dr. Mike, like everybody else, but not you. Yes.
I guess this is just a broad question, but is there anything you would suggest we like focus on or look out for?
That's a good question. So, what I would say is, okay, here's what I think is fair. Between bolted and welded connections, we spent more time talking about bolted connections. So, I think it's fair to say that the exam is proportional in that regards. That doesn't mean that welded connections aren't on there, but I think that bolted connections would probably deserve a little bit more of your time. The other thing I would mention is that I think it's also fair to say that bolted connection problems are just a little bit, they're just longer. I mean, they are, right? I mean, I think that if I give you a bolted connection analysis problem versus a welded connection analysis problem. So for welded connection analysis, you have the connection, just here's the weld metal, base metal again, minimum, you're done, right? But then for bolted connections, you have shear capacity per bolt times the number of bolts, and then you get into bolt bearing, and it becomes a thing, right? It's not hard, it really isn't difficult, but it's just long, right? So what I would suggest, if I was really trying to boil my suggestion down to you, I would make sure that you are very comfortable and familiar with the process for computing the bolt bearing capacity. And I mean every step. I mean, taking the connection, determining LCE, LCI, doing your 1.2 LCTFU, your 2.4 DBTFU. The capacity of the connection is the number of edge bolts, the number of interior bolts, and then don't forget phi values. You got to multiply by 0.75 at the end. Make sure that you don't forget all those steps to get to phi RN. Because I think that you should have that in the back of your head, because that's going to happen, right? And I don't want you to see here's what I could see happening on this exam. Oh, this is easy. And you take your time doing it. Oh, you got 10 minutes left and you only done one problem. So, time management is also, something to be aware of. So that would probably be what I would focus your study on. And the other thing that I think is fair to say that I would focus efforts on is the conceptual stuff. The stuff that's easy to sort of like, that's important, so.
Are there any common mistakes on this exam?
What?
Any common mistakes on this exam?
That's a good question. That's a fair question. So I can't get into too much detail because then I start telling you what the problems are. But I would say that this exam, really just like the last one, but maybe a little bit more pronounced, bookkeeping. Just the bookkeeping on all your calculations. Like, it's easy to not count for something, Here's something I can trace to the last exam. Problem 2 on the last exam was 2. It was an HSS section. And a lot of people were identifying the right failure paths, and, it was visualized correctly. But then when you're computing that area, it's like, no, there's 2 walls. It's not 3 and 2, it's 6 and 4. It's 6 bolt holes and 4 stagger factors, because you didn't account for the fact that there were 2 walls, right? Now, you could have done 3 and 2, but you'd have to double your thickness on your bolts. And that type of stuff didn't happen on the last exam. And it was one of those things like, oh, you didn't do that. That was, minus 4 points here. So that type of stuff is probably a bit more prevalent on this exam, I would say. Not difficulty, just dotting your I's and crossing your T's. I don't think I could say any more than that, because then I'm literally getting into like the problems on the exam. But I think that's the best way I can answer it. Yeah. Uh-huh.
How do you just write conceptual? Like this is 6.
No. This dimension 6, sorry. The reason I didn't put a dimension on that is so, okay, so for that problem, the angle was an L6 by 4 by 3/8. Okay, so let's say this is about to scale as best as it would look, right? So this is 6 inches, this is 4 inches, right? And so if I lay this on a plate, I think it's more natural to sort of lay it long side down like this, so to lay the plate like that, as opposed to laying it on its short side. So I'll say this, if I was redrawing that, I probably would have put a dimension there. So I'll say that one's on me. But I will also say that if they're equal legs, I probably wouldn't put a dimension on there because I wouldn't think it mattered there. So. And to reiterate, I am not going to make you all guess things like whether it's S-min or S-preferred. I rechecked the language on the exam to make sure I specified the electrodes because I boo-booed that on the last homework. But stuff like that, I don't want you to have to guess that stuff. So, I mean, the stuff that I think that you should be able to design and decide on is the stuff we've been covering. So yeah, you're not gonna have to worry about that stuff. Got your capstone report in?
It's submitted.
You got submitted? Okay, all right, cool. What about you?
38 pages, 39 pages.
And appendix.
That's included. 66 words.
Is this scaring you all?
You should know. You should be terrified.
I just know I won't have a hydraulics project at the same time doing capstone.
Yeah, that kind of stuff.
What did I
It's your
do?
fault. It's your fault.
I got that done too.
What's that? What did I
It's your
do?
fault.
It's my fault?
Just take ownership.
You're giving me real good ideas for next year's project, that's all I'm saying. And don't forget, you have the phase after spring break.
Dr. Yoon moved the exam, so we're good there. For Friday.
Oh, okay. So you're okay.
Yeah.
We're gonna move the presentations up. Your groups can go first.
Sweet. 8:30?
I'm just saying, I'm not banking on Interstate 64 having 0 accidents on it. You get what I'm saying?
There's one today, wasn't there?
Yep.
Yeah, that's what I'm getting at.
At Merritt
Yes.
Street,
What's that?
at Merritt Street.
At exit 18, yeah. So the thing, I was, headed in, and it must have did it only affect traffic going eastbound?
Yeah, I think
Yeah.
I saw eastbound.
But the thing about that though is, yeah, it only affects eastbound traffic on 64, but then what happens is everybody gets on Route 60. It doesn't matter whether you're going east or west, it's Route 60, so it's just a mess. So,
That road is. I don't give a damn.
so when I was taking my daughter to school this morning, I saw the line of traffic and then I saw the cops coming the opposite direction. So I was like, oh, I didn't see the accident, but I was like, I kind of saw like that aftermath. So. But that's what I think we're gonna do.
So everybody needs to be here at 8:30 Friday.
But we'll talk about all that on Wednesday. So let's get back to steel design because we have an exam coming up in here. Any questions at all about the upcoming exam? Homeworks, anything we talked about? Anybody nervous about the exam? And if so, about what? Everybody just drained and ready for next week? I mean, let me say this, if you studied the homeworks and the problems we did in class, I don't think there's anything on the exam that's really out of left field. I don't. That's not to say there won't be a problem here and there that challenges you, but not, I find this stuff to be pretty straightforward. And as a result, I think the exam is too. So, and I'll just level with you, where things I think get a little challenging is after spring break, because columns and beams, so I think the best way of saying it is the equations that we've been using so far have been pretty simple. That changes for columns and beams. And so not only does the math get a little harder, but the process to design gets a little harder. We need a lot more resources in the manual than we've been using up until now, a lot more design aids, and the process to arrive at use a W24x76, the process to get there is a little more intricate. So that isn't really the case here. So things will get different after break. That's all I'll say. A little different. Y'all want to end class a little early, or I mean, I'm here. You know, I'm here to earn a paycheck. So you know, put me through the ringer if needed. I can't help with your hydraulics project though. That's the one thing I
Water
can't.
demand for the city of Knoxville.
What's that?
So the water demand for the city of Knoxville. Got those numbers in your head?
No, not at all.
It's at least 3.
What?
It's at least 3.
It's at least 3.1. We'll go 3.1. I have no idea what. Yeah.
I want to reference that. I have no idea.
Just don't put that on this exam.
I'll get Dr. Wade's opinion on it. He'll weigh in.
All right. Any other questions? Y'all want a half hour of your lives back to go work on projects and eat an early lunch? All right, that's all I got. I will see you all on Wednesday.